let me hide some of this other stuff here. And so I will bring in the files that we're going to work with. So we'll open up my folder. And this is our scatter data set. And this is a little bit of information that we already had in from where we defined all the information that we did yesterday. And so we don't really need this right now, so I'm just going to ignore it. But I wanted to look at the merged bathymetry, and then also how to set up these coverages. So I'm just going to turn off this other information right now and then show how to do this. So we right-click on the map data and choose a new coverage, and we'll look through here under models, and we see there is a CMS-Wave option. So we'll choose that option and click OK. It enters that value here. So we can look at the grid. I'm just going to zoom in a little bit to the area. And the next thing is just to define the grid frame that we're going to be using. And as I said earlier, you don't have to be very accurate in this, but you do need to make sure that when you create this 2D grid frame, that your first point is in water, and then you move towards the shoreline, and then define the back edge. All right, and once you hit the third button, it finishes drawing of the grid, and you can look at it. You see here the IJ triad, so it's hard to read. This I is actually right on top of the arrow, but basically this is the I direction, this is the J direction. This will tell us that the waves will propagate from this edge towards the shoreline. So, as I mentioned, you can resize this however you want. I want this to be just a little bit larger than my quadtree grid. So I'm just going to move over here and turn that on and turn the scatter data off so I get about the same size. And I'll just resize this a little bit. And we can see the angle here rotating about that point of origin. So you can do that. So as I mentioned yesterday with the quadtree grid, you do want to make sure that these angles are pretty much, this edge runs along your shoreline for the most part. You don't have to be too accurate with that. But it needs to be relatively close to that angle. And then, as I said, you can move this to wherever section you want, and I'm just going to move it right about to there. It's basically where the waves are coming in, and will start to dissipate. You might, bring it a little bit farther back. All right? And so I'm going to open that back up again and get the values, just so that we're consistently working on this. So I'm just going to enter those values so I can right-click on the center and enter those values that I'm using from before. And you notice these are totally different numbers than they were for the quadtree grid, and that's because the point of origin is in the opposite corner. The other one, the flow grid, it has its point of origin always, no matter how you click out the values, is always in this lower left-hand corner. And for the wave grid, it's always in a certain corner depending on where the water is. So anyway, I'm entering the values here. And you don't have to be exact. So anyway, I've got this, and then we can move forward. So the next step is to create a point where we're going to attach our spectral energy. And so that is going to be, we're going to create a point, make sure that this is still selected. Actually, we need to create a spectral coverage for that. Actually, I guess the next step is actually from this grid frame to create a Cartesian grid. I was about to jump ahead. So let's right-click on the CMS-Wave coverage, convert from map to the grid, and already jumping ahead. I've got to create my resolution, refine points. So for now, I'm just going to go in and I'm going to turn off these edges for the quadtree grid so that I can still see some bathymetry, but I can zoom in a little bit more and be able to see. So we will choose to create some points for our refine points. And so I'm just going to pick a couple of points that kind of are reasonable to me, and we just want to make sure that we have adequate resolution to allow waves to come in here. So I'm just going to click a couple of points like that. You can try various locations of this as you get used to how these grids are created. You'll get a little bit quicker and better at just defining these from the get-go. So we've created those points. I can select those with the select tool, right-click and go into Node Attributes. And I want to refine in both directions, and I will choose 10 meters as the base cell size. So odd term for me. You would think I would say minimum cell size. But anyway, this is the refinement for these individual points. So I'll click OK. Those have been set. And now I can go out and create my grid. So I'll right-click, convert map to 2D grid. I can choose to use those refine points that we just created. We want to make sure that the maximum cell size is some value. It doesn't have to be 200. It can be something less than that depending on your area and how large your domain is. You'll have a good idea once you see it whether or not there's adequate resolution in the offshore. So, and as I said before, this bias starts at 1.1. We can change that just for our example. We're going to use 1.05. You could put 1.08, something like that. Just to be consistent, I'm going to use what's in the notes. And I uncheck the boxes for use in advance. And I showed you examples of that. I can do it again real quick. It doesn't take too much time. So we'll choose our scatter set, go in here, make sure we have the right scatter chosen, and we don't have to worry about any extrapolation since our entire area is covered by scatter set. And we click OK, and click OK. Once you click OK this last time on this dialog, it will go out and create the grid. And so our colors change a little bit, and that just basically says we have transparency on the other grid, but not on this one right now. So we can actually go in our display options and turn on the edges to allow us to see what our grid looks like. And so if we zoom way out, we see what the size of the cells are out here. Zoom into the inlet, and we see that we have decent resolution through this inlet. If we needed to, we can modify the locations of these points. Just delete this grid and regenerate it. I'm just going to go back real quick and generate another grid with different values here. And we'll go ahead and maybe choose 1.08 as the bias and just show what the difference is. Alright, and so this is 1.08. We see what the gradual increasing of the sizes are. as we switch between. And so we just put both grids over here and use the same name, but since there was already one with that name, it adds up to, and it'll do the same thing, it'll add 3, 4, 5, as many as it needs when you generate these grids. So anyway, that was just an example to show the difference between those biases. I'm going to delete this other grid out, and then we can proceed. So now would be a good time, if you're happy with the grid location and how it looks, to go ahead and save your project. And I've done that already, but I'll just go ahead and keep going with this one for right now. So the next step we're talking about, we have the grid, and it's got the symmetry, but it doesn't have any forcing yet. So we need to force this grid. So we'll choose CMS-Wave. We have CMS-Wave menu up here, and we'll go into, we can go into model control if we wanted to right now, but we're going to go into and actually create a spectral coverage to attach the energy to. So right-click on the map data, and we go into new coverage, and we'll find it in general or generic. We'll find a spectral coverage, choose that one, and once it's there, we can select and create a point somewhere along the middle of the offshore edge. Once that point is there, we can select that point, right-click, and choose Node Attributes, and then make a decision on what type of spectrum we're going to be generating. So for a quick case, if you just wanted to see what the waves over this area, just the symmetry look like, you don't care what the waves are, but you wanted them a certain height or direction, you can come in here and create a grid. We have our grid angle of 167. This is set to local. And then we're just going to accept the defaults here for the frequencies and angle fins, and then generate spectra. So this is what I was talking about earlier. We'll just come in here and we will create a wave condition. And so I'll create this, and to use the same values that's from the instructions, I'm just going to use negative 20 degrees. I think this was 2 meters, 8 seconds, and the values were 3.3 and 50. But if you don't know what these are, we have these spectral defaults down here that basically, for the period, it will give you typical values that you can use. So if we don't need those, we're going to just enter our own values here. 3.3 is the same value we're using number of 50 in this spot. So as you see, when I created this, we now have a red arrow here that shows the waves are going to be progressing at this angle towards the shoreline. Once we do our next one, you'll see that change. We'll have 0 degrees, and here you see it's more shore normal, directly onshore. I use the same values as before. And then we'll create another one here at 20 degrees, and we see the representation of that angle. And if we wanted to add more, we can. We can do different heights. So let me just do one more here just for an example. And I'll do, say, 15 degrees, but it's only 1 meter, and it's at 10 seconds. All right. And then specify the seaward boundary depth. And in our case, we're going to be using 20 meters, approximately 20 meters there. So we'll generate, and we see our grids there, and we have our 4 values that we just specified the parameters for. So we can actually look at this, click this first one, and we see what it looks like. You can change the way this appears a little bit with some of these tools. You can change from linear to fill, and see that. You can actually do a rotation and pull this and actually move it around and see what the shapes are. And as I mentioned earlier, you can also pull up the frequency and direction and duration plots and see what these are. So we can leave those up, and as we move to a different angle and a different parameter, we'll see these change, and this value change, we see this direction is right on the 0 line, so it splits the energy from one side to the other here, right down this line. We'll choose the other one, and we see these plots update. And then once we move to this last one, we can see other changes for those. All right? And so that's how you would do individual wave criteria that just match something that you want to see this wave and see how it reacts to the grid that you've created and the bathymetry that you're going to be running this over. The other option here is to import the spectra from some location. Now, I'm not on an ASIC machine right now, so I can't go to WaveNet and run that tool, unfortunately. So I don't have that option, but we kind of showed the presentation earlier. And we have the data from that. And so what we're going to do is change this, close these plots, and instead of using this grid with those criteria that we hand generated, we will delete the spectra. So we'll delete this grid, and instead we're going to import the spectra for CMS-Wave. Let me choose where that's located. So this is under Wave Spectra. All right, and I just need to import that and click OK. So this angle is 167. Click OK, and it imports that over time. We can expand this, and we see all of this information. So you see here we go up to 408 hours, and we can rotate this and look at it like we did before. So we can see what these various waves look like from wherever we got them. So this particular set of information came from WaveWatch 3, which is a model. So you see that these waves are pretty symmetric. All right. And so there we go. So we have the spectra imported. I showed earlier that you can set the update reference time and model control, but if you wanted to, you can go ahead and specify it right here. And so this was basically in the file the date these were downloaded for. It doesn't exactly match the times that we're going to be running, but it'll be good enough for our run, so I'm just going to change these to 2001. All right, and click done, and then we're good to go. So we have the spectra, we have our grid, and now we need to specify the other model parameters and connect in that spectra to the run. So under CMS-Wave, we go to model control. I'm going to choose half plane here. There are a couple of other options, but for this we're going to do half plane. We're going to choose what our half plane grid looks like, so we can specify the number of frequencies and angles. We're going to keep these defaults right now. And then under define cases, we will choose for this number one edge the spectral coverage. I guess that did not update those times, so I might be able to just, instead of doing this, we can just populate some coverage. It still didn't do it right, so let's go ahead and I'll delete all these off and do it as I was actually showing in the instructions. I should have listened to myself. So let's go to update reference time, and we'll change this to 1/1/2001. at 12 a.m. and then populate from the coverage. So we have that information here. So we will click OK, and we'll come back here. We can choose to run with wind if we want and specify that. Just for the purposes of this webinar, we're going to make a couple of changes and then be done. So we will go under bed friction, and we're going to change that to a spatially constant N and use a value of 0.025. We can turn on radiation stresses if we want. We can turn on fast mode just to get a much faster answer. These are the different options for the wave criteria. We're going to just keep it as extended GOTA for right now. Click OK, and then you would want to come in here and file save your project. Then you can come in and CMS-Wave export the wave files. I don't want to overwrite any files, so let me just save into a new directory. So save the project, and I'll go back in and show you what this looks like before we save the files. So we can come in and see that it saved our project. We have the datasets folder, which we've always had. We now have grid, CMS-Wave grid.h5. We have our bathymetry here, and we have our spectral grid also right there. Now these are not formats that CMS knows anything about, and so we can't really run with this. So what we have to do is to come back into SMS and tell under CMS-Wave, we need to export the files that we need to run with. So here we will export CMS-Wave files, and you see it's created a few files for us. And so these are the ones that I mentioned earlier. I'll briefly open these and show you what the format is. So the SIM file, it basically tells what the origin is, what the angle is, and then what the names of all the input and output files should be. So that's all that's in there. In the depth file, this contains the number of rows and columns, some other information, and then values for depth for all of the cells in the grid. And so it has a certain format that it uses, and so you've got that, and it goes on and on. Under the spectra, the spectral energy file, it looks like this. So first it defines the actual spectral grid. So we're running with a half plane. It's 30 frequencies by 35 angles, 167 degrees, and this is the starting energy and the ending energy. Then it specifies the start date, and then we get values in here that have been modified for by the spectral energy that we defined and we imported. So all that information is in there. We can look in this STD file. It's basically a list of cards and parameters. And so this -1, you don't have to know all these, but the -1 basically says fast mode. A 1 is not fast mode. There's a couple of other options based on how you're running, but this is the parameters that CMS-Wave looks at in the file. There's also a struct file that's empty right now, but basically that would contain information about the different structures and the EFO setup. So now you can just go again under CMS-Wave and then launch, and hopefully this will launch without a problem. So we see here it's moving. Let me expand this a little bit for you. Of course now it's not going to keep up. So it's moving through time, through the columns, 225 of 30, and then it's progressing for each one of these. Evidently I had an issue. But I know one of my other cases that I have for you is working, and what I've done is pre-run that for you, and you have those results here in this folder after model control. So I ran that this morning. It finished in about, looks like 8 minutes. The files were written out at 11:09, and then all the solutions were finished at 11:17. So I'm going to load this project real quick. Quickly visualize these. All right. And so it's loading all of the information as we had before, but it's not loading the results. So when we load the results, we can just pull these different files. So you see here it's created a .RAD file, that's the radiation stresses. It's created a .WAV file, that's all the other information that pertains to wave, it's got your wave height, period, direction, and then it also creates a vector showing the directions. So let's just pull this wave file directly into the interface. And in the meantime, it's loading. This grid's relatively small, so it's not taking terribly long. So I'm going to turn off a couple of other things just so we can see this better. So we'll turn off this grid. I'm going to go in and turn off my cell edges. And so we'll look at the wave height. And we see this also, this vector data set here you see with the arrows, but you don't see any information right now. So let's go under display options again, and we'll actually turn on looking at those vectors. And then under the vector tab, we can change how we represent them. So I'm just going to leave this by the default at first. And it basically puts an arrow at every cell. And so as you move in, it's really messy. You don't really see a whole lot of information here. You'd have to get really far in. So what we normally do is we'll go in to that vector option and actually change it from showing at every node and cell. We'll choose to show that on a normalized grid. And so those are separated by a certain number of pixels each. And you can change how this appears on your screen. So I'm just going to choose 2020 for right now. There's some other options as far as what the arrows look like and what the range could be, but I'm just going to accept the defaults for this, and we update this. And so we see this range of vectors. You can kind of see through the inlet, but as we scroll in, you can see actually more and more cells through here, and the energy that's coming into our wave, our inlet and bay. So the colors here are the wave height, and so they vary. There's 0 back here because all of this is land, of course. Out here, you can look at the bottom here, and as you're scrolling with your cursor, it shows you a value 0.31, 0.29, 27, 0.4, and out here on the offshore edge, it's right about 0.4 meters. So this is pretty quiescent at the time, so 0.4 meter wave height. You can also look at the period, and so it updates the colors to match that. And so what we can do is, if we want to see a better range, go in here and change the contours. I'm just going to uncheck this box for the range, that way it'll update for whatever data set that we have selected. So here we see the period, and so this is 3.4 meters, and it's pretty, 3.4 seconds, and we can see if that changed at all. It's pretty consistent through here. Direction, you can look at it, but you don't really get a lot out of looking at directions in the scanner. You get that information already by the angle direction, so we can normally just forget about looking at the direction data set here. So that's pretty much it. So we have our wave heights, and we can see how the energy just drops off back here. As we get into the inlet, it turns to this lowest value of 0. We can see we're already back here, we're less than 0.01 meter wave height, and so the wave energy quickly dissipates as you move through this inlet. That's pretty much it as far as looking at these results. So that is creating the CMS-Wave grids. I'm going to go ahead and quickly open this up for questions to see if you guys have anything before I move on to the steering part. So let me unmute your phones real quick. And I'll just give maybe a couple of minutes. If I don't hear anything, I'll go ahead and move on. Okay, any questions? Very quiet out there. Okay, so if there aren't any questions, I'm going to open this back up again in a little while after I finish showing the next few things, but I'm going to go ahead and meet you guys again. All right, so we have, at this point, I'm going to go ahead and turn off, I guess one thing I didn't show just before I move on, we did load this data set in and we looked at the various data sets. I didn't quite show this through time, so let me just go ahead quickly down here. I'm still looking at the wave height, and through time we can actually see these directions move and the colors change for these wave conditions as we're moving through time. So that's just a quick way to go through. I'm going to show a little bit more tomorrow, but there is a way through this to do film loops and capture all this, and so you can see, capture a little AVI and then show it without having to load all this data back in. So anyway, that's looking at the wave results. So at this point, we've got a wave grid, we've got a quantry grid, and so we could, I'm going to go ahead and delete these answers real quick, the solution. And so we could actually, at this point, start a simulation where we're running both waves and flow together. And let me just quickly show you how you set that up. Not sure why these colors look so bad when we're overlaying both of these together, but I'm going to turn one of these off for right now. Probably just the colors that we're looking at for these aren't at the same range. So when we do a steering run right now within SMS 13, all of that is done through the CMS flow model control. So let me switch back over to our quantry. I'll turn this off and back on here. We've got our simulation data is still here, and so what we want to do at this point is go back under our simulation, and we will right-click and go into model control. And so now, and there was before, but there is a wave tab, and so what we need to do is basically tell SMS and CMS that we're going to be running our CMS flow also with wave input. So we would change this, and in our case we're going to be running with the inline steering. So turn that on, and it gives us a few questions here. So we need to specify where this wave grid is located that we're going to be running with. And so we're going to browse for the file. I'll select and go out and find it in the directory. And so it's already in the right directory for us right now. So we need to normally we point to the parameter file or the card file that runs the specific model. In this case, it's the .sim file for SMS, for CMS-Wave. So we'll choose that. We'll click open, and so it pulls it in right here. And we want to know now what the steering interval is. So if you remember, when we pulled in that wave energy file, it had output every 3 hours. So that's up to the user what interval you want to get that information for. I would say that 3 hours is probably the longest or the largest interval that we sometimes use. Occasionally, if it's a really long run, we'll do 6-hour waves, but 3 hours is probably the longest that I would want to go between updating my waves. But you could get your wave input at every hour, 2 hours, something like that. And that's just all in the method where you're going out, grabbing the information from those gauges or models, and then formatting it for CMS-Wave. So in our case, at this point, we're going to be running with 3-hour interval waves. There's an option here for how are we going to predict the water levels as we move through the wave grid. And there's 3 options. There's the last time step, there's tidal, and then there's tidal plus variation. And we default to that last one, the tidal plus variation. Essentially, since SMS and CMS knows the time frame we're going to be running, and we have the location, latitude and longitude of the grid, we know we can project some astronomical values for tides. And so this option allows us to use that time and spatial information to help give a more accurate estimation of what the water levels are for these waves as we're projecting them. Because I quickly mentioned yesterday, we're actually pre-calculating the waves before we actually run the flow. And so we don't really know at the time we run those waves what the actual water level in our flow grid is. And so this kind of helps us project that information and feeds it the information that it needs into CMS-Wave before it runs, because it knows that I'm running this and I'm in a certain location, and this is for 3 hours from the current minute. And so we can project with those tables, those side tables, and figure out what the water level should be. And the plus variation is basically the last time that it ran a wave calculation, it knows what we estimated, and then it sees what the actual water level is at the end of that flow run, and it has that variation, and it can actually use that little bit that it was off to help improve the calculation. So anyway, we use the value here, tidal plus variation, the default. Don't worry about changing this. And then extrapolation distances, we don't really need that in this case because our wave grid is larger than the flow grid, but it's good to just choose automatic here, and if it was smaller or larger, it automatically decides how far it needs to extract information, both from the wave grid to the flow grid and from the flow grid to the wave grid. So once we set all that information up, we click OK. Actually, we could, if you want any wave output on your flow grid to look at, you could actually go into the output screen and turn on waves. And the different data sets, you automatically get wave height, period, and the vector. but you could turn on dissipation if you wanted to look at what the wave dissipation was. And then you get a choice of what list of times that you want to use. And so since these are every 3 hours, I'm just going to choose list 2 that kind of matches that right now, and so we have 3-hour wave output. At this point, we would click OK and then save our project. Let me do that. I'll just save into a new location. So I'm not going to overwrite anything. I'm just going to overwrite in the step directory here. Save. And then I would go in and right-click on the simulation, tell it to export the CMS flow files. And I'll actually open those up real quick and list those. So remember, it creates a directory structure here for the CMS flow runs. And it's actually still calculating here. You see the spinning icon. All right, and now it's through. It's got the CM cards, the world fill, the datasets H5, and then the model parameters H5. And so we can actually tell SMS now to launch. And hopefully, I haven't tested this out, so hopefully this will actually run without dying on me. So let's try it out. Okay, so it's actually running the waves right now. So it's going to, the first one, it's going to run the 0 time, and then it's going to run a second time that is for 3 hours later. And so that'll do that in just a few minutes after it has finished calculating these interpolation coefficients. Normally it just takes a couple of minutes depending on the sizes of your grid. And once these coefficients have been calculated once, if you go back and rerun, you make a couple of changes to the symmetry or the parameters. This information is not going to change, so it keeps that information and it won't have to recalculate these next time. So now it's gone through and it's calculating the second wave condition for 3 hours later. And now we're starting the actual flow. So this is a flow with waves for that first 3 hour period. We're already moving around sediment. We've seen some values here starting out. And so this is the process that you would go through to run. So I'm not going to wait for this whole thing to run, so I'm just going to go ahead and abort and open this back up for discussion. This is about where I wanted to end the day. And so if there are any questions, I'm muting your phones. Feel free to ask away, and we'll stick around for a few minutes. But otherwise, if there are no questions, you're free to go. And we're going to cover, tomorrow we're going to cover a little bit of post-processing, building film animations and doing some other graphs and plots and things like that tomorrow.